Right. So my talk is going to be pretty technical. I'm going to go one level deeper than Morgan did and tell you about various Vitess concepts, and then we will use those concepts to put together a cluster that is jurisdiction aware, that basically solves the GDPR issue for you. And Miriam had told me that that's one of the things that we want to solve here at Beam, because you ingest data from multiple, I don't know how many of you are Beam folks here, but we ingest data from multiple providers with HIPAA requirements, and they need to solve this. So quick introduction about me. I have worked most of my career as backend infrastructure engineer at companies such as Google, YouTube, Dropbox, and most recently, before I started the company, at the United States Digital Service. If are any of you familiar with USDS? So do you remember the healthcare.gov fiasco a few years ago? So when that happened, a bunch of engineers from Google went to Washington, D.C. and helped bring that site up. And then that group was sort of institutionalized into a small department that reports directly to the White House. It's called United States Digital Service. And they're doing very well. So find out more about them. So I used to manage the site reliability engineering and DBA groups at YouTube. So my groups were responsible for running the Vitess clusters at YouTube. Me and my co-founder Subbu, who is the main developer and brains behind Vitess, he and another developer at YouTube, Mike Solomon, founded Vitess in 2010. So Subbu and I founded Scale in February 2018. It's a venture-backed company. We have raised capital from A16Z and Simplifier. We are now 30 people. We are based in Mountain View, California. So what are we going to cover today? We are going to first talk a lot about Vitess overview and concepts. Then we will use those to solve a problem, which is how to create a GDPR-aware cluster using Vitess. And then I'll demonstrate this to you. So I think Morgan talked about this diagram in fair amount of detail. What I want to draw your attention to here is the shard 1 to shard n, right? What's a shard? A shard is basically a database cluster that has one master, multiple replicas. The replicas are replicating from the master using the standard MySQL binary replication, right? Nothing to do with Vitess. So each shard is basically a bog standard MySQL cluster with masters and replicas. These n shards constitute what we call a key space, okay? So a database in Vitess parlance is called a key space. And the reason that we call it a key space is because each shard covers a certain range of the possible values that the full key can take. So if you take like a 64-byte number and 0 is the minimum and FFFFF is the maximum, that's your entire key space. And that is divided into n parts, and those are the n shards. So that's why a database is called a key space. So basically, a key space with just one shard is a MySQL database cluster, right? So each of these shards has identical schema. We will go into these concepts a little more later. Vitess has a full MySQL parser. Vitess looks at your where clause, figures out which shard the query should go to. And how it does that, we will look in subsequent slides. So sort of remember this diagram. We will be referring to this in subsequent slides as we go. So let me talk about a few concepts. I'm going to first start out by talking about cells. I think when answering a question during Morgan's talk, I said that there were 20 cells that YouTube data was spread across. Now, what is a cell? A cell is basically a failure domain, right? It's a group of servers and network infrastructure. Isolated from, it isolates that particular bunch of servers and network infrastructure from other cells. And these are a few examples of how you could sort of logically organize a cell. It could be a full data center. It could be a subset of a data center, like an availability zone, or it could be a Kubernetes cluster, or it could even be a rack in a data center that you yourself are managing. So a cell is basically a failure domain, and it's isolated from failures in other cells. I talked about this a little bit. What's a key space? So key space is basically a logical database. If there is no sharding, key space is identical to a single MySQL database. If you are using sharding, then a key space maps to multiple MySQL databases, all with identical schema, which span the whole key space. In either case, a key space appears as a single database from the standpoint of the application. The application does not need to be aware that there are multiple database clusters that constitute this key space. The application can continue to treat a key space as though it's a single humongous database, right? So that's what a key space is. Now we are going to go a little bit lower down and talk about the key space ID. So key space is sharded by key space ID ranges, and each row is assigned a key space ID. So every row in every table in the sharded key space has its own key space ID. Okay? And if you are familiar with things like MongoDB or any other NoSQL system, this key space ID is like the sharding key that something like Mongo would use. Does that make sense? But in the case of Vitess, we do things more cleverly. It's completely internal to Vitess. We do not store it anywhere, but we compute it when it's needed. Okay. And how do we compute it, right? We compute it using this other concept called V-index. So a V-index is a way to compute key space ID for any row in a table. So V-index for a table is defined by two things. One is the column name that you want to use for sharding that table. And the second is a sharding function that you want to apply to the value in that column to figure out, to basically calculate the key space ID. So key space ID for a row is equal to sharding function applied to the column value for that row. So that's how you calculate the key space ID for a row. So for example, let's say that there is a table called customer. It has a column called ID. And we use a sharding function called hash. Then for a row where the ID is 123, the key space ID would be hash of 123. Make sense? That's how the key space ID is computed for every row. Now we will see how that key space ID is used to figure out which shard a particular row should go into. So each shard has a key space ID range that it spans, right? So there's a begin and there's a begin value, there's an end value. So begin less than key space ID less than or equal to end value. If that condition is true, then that particular row with that particular key space ID belongs in that particular shard. Very straightforward, right? And each shard, as I said, has one master and multiple replicas. And every replica and every master is located in one or more cells. A cell is something that maps to a physical location or actual collection of servers, right? So I said that for every table, you specify a sharding column and a sharding function. The cool thing is that you are given these 7 or two of them are the same, binary and numeric are the same. But you are given these predefined sharding functions by Vitess, right? If you say that my sharding function is binary, it's basically identity. Whatever number you give it, that's your sharding key. So if you are somehow using a hash column or something like that in your schema, you can just use that as a sharding key. Or you can say that it's binary MD5, that's an MD5 hash. You can say it's hash, it's a 3-days null hash, null key hash. You can even have a numeric static map, which is basically a JSON file that you supply to Vitess, which maps input values to key space IDs, right? So very, very flexible. The Unicode loose MD5 is what you would use if you want to use a varchar or a var binary column for doing your for doing your sharding key, right? So if you want to use like first name or something like that, and somebody wanted a bit reversal as a way of computing this. So these are the different functions. You choose the column, you choose the function that gives Vitess a way to compute your key space ID. It uses that key space ID to figure out which shard your node should live in. So remember this. But the cool thing about this is that these 7 functions, they are just, I mean, there is nothing magic about them. You can write your own custom sharding function. And today, we are going to write a custom sharding function, or rather, I have written it, and I'm going to show you how that works for GDPR compliant clusters. So what are we going to solve today, right? Let's look at the problem statement. We are going to create a database clusters that stores data for a given country in the jurisdiction that it belongs to. And it's not that hard to do. If you just say that if country equal to USA, then you connect to that database cluster. You can have this really elaborate logic in your client application. And of course, you can have a cluster like this. But what we are trying to do here is that the client application did not be aware of jurisdictions or countries at all. Or rather, it is aware of countries because it's part of the schema, but it's not aware of jurisdictions. It's not aware of physically where the clusters are and so on. So you want the application re-engineering to be as minimal as possible as you start using these clusters. So for this demo, we are going to say that there are 4 different jurisdictions: Americas, Asia, Africa, and Europe. So those are the 4 jurisdictions, and each jurisdiction there are 2 countries: France and Germany in Europe, Kenya and Nigeria in Africa, India and China in Asia, USA and Canada in the Americas. So 4 jurisdictions, 8 countries. So how are you going to solve it? Right? Remember we talked about cells. So we are going to first create 4 different cells, each corresponding to a jurisdiction. So there is going to be a cell called US West that corresponds to Americas, Asia, one for Asia, Africa, one for Africa, Europe, one for Europe. And then we will create a key space with 4 shards. And the master for each shard would be resident in each cell. So because I don't have too many resources, I haven't created any replicas. So our key space will only have 4 masters, and we will start each master in each cell. And then comes the interesting part. We will create a custom v-index called custom geo, so that the data is distributed correctly using the country field in each row. Okay. So we will use this map for mapping a country to a jurisdiction. So this is just basically a JSON file, and this data structure allows me to, given a country, I can find a pipe that it corresponds to. So let's say that the country that I want to figure out is Canada. So the jurisdiction for Canada is Americas. So Americas is the range is 120 to 192. So I take 128 and add the index in this list of countries for Americas to 128, and that gives me the pipe that I will use for Canada, and that's 129, right? For China, it would be 65. For India, it would be 64, and so on. Right?
Doesn't it have to be above the beginning?
The last, that 64 is not used basically.
Oh, okay.
That is just an upper bound, and then the code starts from 64. This is the sample data that we will insert. Philip Roth and Gary Shteyngart are two of my favorite authors. So I went to Wikipedia and pulled out names of authors from various countries. So there is an ID. The way we generate this ID is interesting. I will show you that in the demo. There's a name, then I created a national ID that approximately looks like a social security number, and the country, right? And the idea is that based on the country, the data should correctly distribute itself to the correct cell, to the correct shard, which corresponds to the correct cell. So now we will get out of this and we will do it.
If you can't see it, I can change the scale on for you.
Okay.
You should be able to Apple Plus it as well to make it bigger.
Yeah,
Just Command Shift plus.
it's just all messed up. Well,
Go onward.
it will. I'm just saying everything's going to be small scaled at English. I'm just going to rescale it.
Okay.
So that way when he goes on to whatever else he goes on to, it's also prefixed. Sorry. I told you I'm here to make sure things work. I don't know why they've been, it's been re-default. There you go. So now it's at least better by default. And if you can't see into that, you can still Command plus or Command Shift plus and
That's gonna be real big.
get it a good size.
I definitely read that.
Is this readable still? Yeah. So let's go here.
They own one.
Why is that?
Relying on the local DNS server.
I tested this.
On this network? Isn't your config like, is it SSH config or you're relying on,
It's in my SSH.
okay. Because it looks like it's not noticing it by that in your config.
Name or serve name.
Let's get straight. Where we are.
Nice.
So I'm going to start the cluster now. And as the cluster is starting, I'm going to show you exactly what is going on, right? So remember all the cluster metadata, if you think about the architecture diagram, all the cluster metadata was saved in a topology server. And that topology server is the first thing that comes up, which is we started 3 bookkeeper servers, and that's our topology cluster. We started the VTCTLD, which is the control plane for Vitess. And now we created a first key space called lookup, and we applied this V schema to it. There are 2 tables in that key space, one called customer country map, and the second is a customer sequence. So remember, somebody had a question about sequences. This is a sequence that we are creating. So what I'm going to do while this is happening is I'm going to give you all the URL. I think it will be hard. Is there anything that we all have in common here?
Or Slack.
Well, we're all people. What do you mean by comment?
I mean, you could use Twitter, I guess,
Right.
but That's the only thing.
We have a Slack channel for the meetups.
Oh, we do.
Yes, so it's the invite to it is I don't know, Derek, you have any right off the top of your head? I keep changing it.
So here's what I'm going to do. I'm going to send it on company Slack to Morgan, and Morgan will see if he can send it to you all.
I can put it on there.
You can actually, okay.
Yeah, I will send it to you because I know how to get more of you.
The Vitess one.
Yeah.
So, okay. So we start, so I'm going to show you how this cluster looks like now. So we created two key spaces, okay? The first key space is called lookup, and that has only one shard, okay? There is a second key space called userdb, it has 4 shards, okay? Let's look at the topology. These are the four cells that I created. Remember Africa 1, Asia 1, Europe 1, and US West. And if we go back to the dashboard, if I look at the shards, you can see that dash 40 is in Europe 1. Okay. 4080 is in Asia. 80C0 is in US West. And C0 dash is in Africa. Can somebody tell me why these shards are named the way they are? What does 80C0 stand for?
I was just guessing, but they look like IP start address ranges.
No, they're not IP ranges. They are the begin and end values for the key range that that particular shard serves.
I was thinking like the 128.
So this is basically, remember, for each row you compute the key space ID, and then you check to see which shard it should belong to, and anything that's between that begin value and end value, so 80000 and C0000 would belong to this particular shard. So this is the begin and end for this shard. So if you look at these 4 shards, 0 to 40, 40 to 80, 80 to C0, and C0 to FF. That's the full key range that is being spanned by these 4 shards, right? Vitess also allows you to take a look at the schema. So if you look at this lookup, there is a customer country map which maps an ID to a country, and there is a customer sequence. This is the spatial table that you need to create for supporting sequences. This answers your question, I think. So take a look at the cache value. So it's the cache is what tells you how frequently this particular thing is going to get written down. But otherwise, it's going to just keep handing out IDs using this particular table. And if we go to the user DB, and this is where our actual data is going to live. And this is ID, full name, national ID, and country. This is the schema of the customer. And this ID is going to come from that. Okay. Let me show you how the V schema looks like for this particular one. So this is the custom. So we define the index called GDPR VDX here. Its type is geo custom. So this is the 40 or 50 lines of Go code that I wrote. I defined the name of that particular index type as geo custom here. And these are the parameters that it is taking. It uses ID as the sharding key, but it also does a secondary lookup on the customer country map to get the country and then figure out that byte that needs to go in the front, and then it does the sharding using that. So what this allows you to do is that if one particular country has hundreds of millions of users, and if you want to reshard that users in that particular country, all of this will work as expected, because the sharding, the space ID that gets generated, the first byte will be identical, but everything else will be different. So you can take that shard for North America, shard it into 2 shards, and everything continues to work. Right? And here what we are doing is that for this table for customer, we are saying that shard this table using the column ID after applying this index called GDPR VDX, which we defined up here. And let's take a look at what this is. This is being provided as an input to this custom index. And this was our mapping function that I had showed you about, right? So now, after all this is done, let's try to write data in here. So it inserted these 16 rows. Now if we come here, if you look at the schema, you can see that the customer country map has 16 rows. The customer sequence has only 1 row. If I go to user DB, this shard has 4 rows. This shard has 4 rows. This shard has 4 rows. And this shard has 4 rows. Are they the right rows? Let's try to figure out. So let me show you what is there in this file called showgdpr.sql before I run it. So Vitess does allow you to address each shard separately. So if you just say use user DB, it's going to give you the view that it's a single large database. But if you want to talk to a specific shard, you can actually say things like use user DB-40, and then you're talking to only that particular cluster. So when I do this and do select star from customer, this particular shard, according to our schema, the -40 shard belongs to Europe. So if the first, this should give me the first should come the rows from Europe, which are French and Chinese, German rows, then Asia, then Africa, then the US, right? So I'm going to run this command. And you can see that this is I'm using the standard MySQL client, and I'm giving it this SQL file as an input. And you can see that from -40 Europe, 40 to 80 is Asia. Next one is Americas, and the next one is Africa. And when we finally just say use user DB, it gives me the 16 as the count. Does that make sense? So we can just go in here, and I can say use user DB, and I can say select star from shows me everything, right? I say customer -40. Now if I select star from customer, it shows me only the French. So that's how you can create jurisdiction compliant clusters using Vitess. The trick is to write your own v-index, which takes whatever indication locality you have in your data and uses that to correctly shard queries to a specific shard. And then you pick up your shard in a cell which is located in that physical location, and you have the problem solved. Question?
What happens if
you have your stuff in one country and you try to query everything across all your users and the whole country's cells down, does it error out? Does it only give you the results from the responding cells? And I imagine that's quite different between MySQL and gRPC.
It is different. So I think, do you want to take that?
Slack added a mode. There's a lot of like special comments as like a way to send things over the MySQL protocol. And Slack added a mode, I'm pretty sure, that will return whatever results are available.
You might want one or the other, right? Like that.
Right. I think by default, it's all or nothing, but you can opt into best effort.
Yeah, by default, you would say that I don't have masters to send the queries to that span the whole key space, so I'm going to fail your query. But even in that mode, if you actually start say that, okay, don't use user DB, but use user DB -40, and if Africa is down, we'll still get queries from here.
Okay. Cool. Curious.
What's the thought around like, I don't know if it's like cascading indexes or if you just have to write your own, if you want to do, by jurisdiction, but then do a true shard.
After that, right?
Yeah.
So this will support that. So let's say that, you have the first byte of every key space ID that gets generated for somebody in the United States would be identical, but everything else would be different. So if you take that shard range and you shard it, if you run the resharding workflow, they will all be sharded correctly.
But you still just have to do your custom sharding function.
Yeah, once the custom sharding function is in place, the rest of the resharding workflows just work. Right. I want to show you one thing that is kind of slightly tricky here, where I'll show you how I'm inserting these rows. So there are two different insert statements. The first one is I'm inserting into the customer country map just the country, right? And this actually generates the ID and gives me the ID back, which I'm using here. Does that make sense? So I add the country to ID map, that gives me the ID, and then I use that ID to actually insert the row into the customer table. Typically, you don't need to do this. Typically, you would just insert the ID. You would just not give the ID. You would give ID as null in that second insert. And if you have set up that ID to be a sequence, it will just generate it for you. The reason that I'm doing this is because during that second insert, my code that does the actual figuring out of the key space ID needs to do a lookup to get the country associated with that ID. Because the only input that function has is the ID itself. And it doesn't know anything about the country. It doesn't have the view of the whole row. So it needs to do a lookup, which it does into that country ID map, gets the country, and then does the rest of it. So, any other questions?
Can we see the actual sharding function?
Yeah. So you want to see where it lives. Okay. So as you can see, this is byte for country, and this is basically parsing that JSON file, getting that byte. I showed you that it's 64 for China and whatever it is, right? And let's see where it is used. So this is basically each v-index has this map function, and this map function is the one that I changed. So what I'm doing is I'm getting country byte using this particular function. And once I get that country byte, what I do, ID has been given to me as an input. I use the bin hash function on id.2bytes. So if I was just using a hash as an index, that's all that would have happened, right? So I get this value, take 7 bytes out of it, and then I combine that with the country byte. And then finally, I take that and use that as my key space ID for the ID that was given to me as input. And once that happens, it's just done. So even before I come here, I need to figure out, look at this. This is basically ID to country, right? Because I've been given ID, I need to do a lookup on that in the lookup database to get the country associated with the ID. So that's happening in that first line. So I get the country, and then I use that to figure out the byte associated with it. Then I take the ID, I hash it, I put the byte and the hash together, I truncate it to the number of bytes that I want, and I'm looking at the space ID associated with that row.
So this isn't a bad thing, but this is also going to be hard to get around if I were to say like add South America or something, right? I'd have to either reshard or redo all my keys or something.
Well, you do it, right? That's why that JSON file is there. You just add South America to whichever jurisdiction you want. It could be
As long as I have room in that byte.
Yeah, it could be a country in Africa. So that's why the byte is 256. Number of countries is less than 256.
But yeah, and that's why in this case it's kind of bad, but
Yeah.
you do need to plan ahead. Okay.
And the thing is that I don't even know whether this particular, the reason that I wanted to do jurisdictions is because EU is a jurisdiction and there are multiple countries in it. And I want to sort of show that model, right? I could have just said this country, this byte, and I could have hard-coded that. And that would have made this code a lot easier. Or let's say that I don't want to use country as a geographical marker. I want to use a zip code as a geographical marker. If I want to do that, that's obviously more than 256. I probably need to use 2 bytes to represent that, and then the rest of them I can share using the hash of the ID. Right?
So
the basic idea remains the same.
So in addition to that, this is also useful for like you can layer the cells so that you can write from anywhere, but it's actually just geo-distributed to the one place it needs to be in, and then can only be read from that place or whatever as well, right? Like you can layer this really, really tightly.
Absolutely.
Okay.
You can only look at a particular cell, and then you layer the clients from that particular geographical region only down to those VT gates. They are not even aware that there are other.
Yeah. Okay.
Yes. And the cool thing about it is that once you set this up, if you had a monolithic database, reshard using this, and all your rows get distributed correctly. So you don't have to worry about re-engineering your application, and you are compliant. Yeah. You can provide a database and all your data is distributed correctly.
Or even if you already have like geo-distributed databases that are separate monoliths,
That's right.
you can reshard them all into the same engine, and they still get distributed backward. Yeah, that's awesome.
So some people that are coming in, that have some kind of predetermined sharding model, they'll do a custom Vindex, not even for long-term, but just to let Vitess know where the data lives today and then reshard it however they want to a different sharding model. But this is a good way to kind of pretend Vitess knows where your data is supposed to, I mean, not pretend, but hack it, I guess.
Redistribute.
Yes.
How does a physical shard join the set?
So when I start the tablet associated, remember the VT tablet MySQL combination that's a tablet. So that VT tablet process takes a parameter which says that this is the key space name and this is the shard ID that this particular MySQL is serving, and that information gets stored here in the etcd cluster. So if I look at US West and look at key spaces, you can see that particular, so that's
there, then it can,
and so VT tablet, once it starts, it registers that information there. It's consumed by VT gates when the queries are directed there. Questions?
I've got another comment. So at YouTube, they were super read heavy, so they had a ton of read replicas. For what we do, we're pretty write heavy. And so, but at the same time, as soon as you start doing a bunch of read replicas, now all of your app devs have to deal with eventual consistency, which they're going to do wrong.
Actually, yeah.
So what we do is we run less we don't do any read replicas. Everything we do connects to master, and if we need more throughput, you just shard more. And so we're only dealing with, strong consistency, except for we have some edge cases for metrics or some heavier queries that we hit the read replicas where we know that we don't care about.
So the interest, so let me show you that basically, see how we were saying, here use user DB and you say select and it goes to the master. If instead I had said use user DB at replica, then that particular query would have been load balanced across all the replicas from that particular shard. And if I had said, so typically when we think that app is the correct place where you decide whether a particular query needs to go to master or whether it can go to replicas. Vitess is not the correct place to make that decision. Because the very classic example at YouTube was that if I was making changes to my own profile, I wanted read after write consistency. Because any changes that I made, I wanted to be reflected immediately. But I was looking at your profile, it doesn't matter if it's a few seconds state. So then you can send that query to user DB at replica. And those queries actually you used to only get load balanced across replicas in the local cell. So Japanese users would read from the databases in Japan and so on. And that's why we had 4 to 5 replicas per cell, because local clients would read on local. And the writes they would not.
Can you group tablets too? Like, you can group in like the replicas only or whatever, but can you say like, I would like to read from these 3 tablets in the cell or something?
No, you cannot. So I don't think you can actually address this user tablet. You can only say user DB at replica and it will load balance across all replicas. But you can specify that I will only tolerate a replication lag of so much. And any replica where the replication lag is higher than that will be dropped out of the serving quota. So then they will not be load balanced across these. And we support 2 different types of replicas. So there's at replica and there's at RD only. So at RD only, typically you have bad jobs that are going to run stuff for a long time, and you don't particularly care about the application lag or anything. You don't want those bad jobs to push down your serving app. So those are the second set of replicas where we don't keep tab on the replication lag. And those replicas are never used as candidates for becoming a master. Only at replicas can become masters.
What's the big data tablets that showed up in both the diagrams?
That's because RD only and replica are such a confusing things.
Oh, okay.
Big data are basically RD only.
Okay, that makes sense.
Is if I create a user in MySQL, I can start doing all sorts of fun things. I'm sure there are limitations with security in MySQL, and that is at least the user replicated across all tablets.
So VTGate has its own set of users because application is connecting to VTGate. And then VT tablet finally ends up talking to your MySQL. And the VT tablet to MySQL, those users and their passwords, those are configured separately. And that's a one-time configuration. But the app to the VTGate, which otherwise would have been app to the database, that's a different. We support TLS, we support certificates, certificate-based users, but we also support the standard MySQL.
Can you serve multiple key spaces off of a single tablet?
You cannot. But what you can do is you can start multiple VT tablets in front of a MySQL which has multiple key spaces in it. But we don't recommend that you run that way. We recommend one key space per MySQL instance at 250 GB. Any other questions?
So at YouTube, were you actually streaming from?
No.
You were just using the profile, other information that was the metadata,
In fact, user metadata and video metadata all came from the system.
probably streaming out of some block storage or whatever, object store or whatever.
And CDN.
Yeah, CDNs all over the world.
The Google internal system was called Band-Aid.
Band-Aid.
That's all the questions?
If you ask the question, we like some socks, come see me. Honor system.
Feel free to
I'd
check out
actually like-
more food.
Awesome. And thank you very much for hosting us here.
Let's get both of them. Actually, someone else here too, sorry. All three. Very fascinating. So, and we have little tokens. Oh yes, yes, with the Kubernetes logo. Thank you for coming. I'm sure that there are on the slides, people want to contact you or other information interested in the company and the technologies. Those will be in the slides themselves, I assume.
I would say join the Slack chat, the Vitess Slack channel. It's a great place. Derek's in there. Everyone's in there.
It's the easiest way to get a hold of Derek, actually, is the Vitess. So,
You can get there from the planetscale.com homepage.
Vitess.io homepage.
Planetscale.com.
Also, okay, cool.
Also, we have a double feature this month for Kubernetes meetup. Next week, we have another one as well, kind of cloud agnostics. It's all kind of on the website what it's going to be about. We have somebody from Denver who's coming to talk about that. It's going to be very interesting. So please invite your friends to come as well. So thank you for coming. There's still more food, guys.
I started working on it. Right. Testing didn't.
Have you seen the